Hi students, I'm going to graph the cosecants and the secants for you. Again, you'll probably find 2 or 3 different ways to do this. I'm going to do it differently than the book. I'm just going to do it the way I know it. And here we go. If I have graphing of the cosecant, I really don't like thinking about the formulas involved in this or anything. I just want to think of it as the sine of 2 theta. And I'm going to get all the relevant points for this, just like I was doing sine of 2 theta. But when I'm done, I graph it a little bit differently. Let me show you. Okay, step 1, find the period by doing 2 pi over b. Remember, just think of it as this. So 2 pi over 2 is pi. So in this case, it's pi. Then step 2, find your 5 critical points, just like we always do. Start with your phase shift or 0. There is no phase shift, so I'm going to start with 0. And I'm going to go to pi. So because I need the 5 critical points plus 0, I just take 1/4 of pi, and that's what I'm dividing by. So it's 1/4 pi, 2/4 pi, and you can simplify if you want, 3/4 pi, and this is 4/4 pi, right? Or 1 pi. So at that point you can simplify if it helps you. That's 1/4 pi, pi over 2, and that's pi if I simplify those values. Now I'm going to determine the sine values of these. And I know that my sine always starts with a 0, right? I just think original sin, I think the origin, the sine always goes through the origin unless there is some sort of a phase shift. So I know the 0 is 0, and then the maximum's going to be 1, and then it'll be -1. Oh, then it'll be 0. Sorry, then -1, and then 0. So I've just finished the third point as well, because the second point was to find those 5 critical points, determine the phase shift, so that you can do the midline and the maximum and minimum. So now that I've determined the sine values, I understand that the cosecant is 1 over the sine. So every stinking place where I see a 0, those are my asymptotes. So I'm going to graph that. Let me show you. So let's say this is it. I'm going to number it. So I numbered it, and I probably should go on over here. This is -pi over 2. I just did it by fourths because that's what my chart is. So I went ahead and did it by 1/4 intervals. And now I'm going to graph my vertical asymptotes, and I'm going to explain why those exist in just a second. So here's one at pi over 2, half pi, there's one, and at whole pi. So now I see a pattern, and there are my asymptotes. And the reason why those occur, let me show you the unit circle. Okay, because the sine of 0 is right there and right there, correct? So every time I hit those points, I have a vertical asymptote because it's going to be, instead of 0 over 1, be 1 over 0. I put 0 in the denominator. And so that's why I have these asymptotes on this. So let me finish graphing. Let me make it bigger. Now remember, everywhere I found a 0 on my chart, I just did the sine, I created a vertical asymptote. Everywhere I see a maximum value of 1, that is now the bottom of what looks like sort of a parabola. So let's say this is the 1, and let's call this a -1. So at 1/4 pi, which is right here, the 1 is the bottom of this asymptotic graph. And so it is here. Oh, big mistake. What am I doing? Because that is a -1, right? Silly Miss Wilson. There we go. Then this one will be up, because the positive ones are my minimums, the negative ones are my maximums. So notice that the periods are actually cut in half, because you have, even though it takes 2 pi to get around on the sine values, every pi you had, let me show you again, every single pi here and here, you had a undefined value for your cosecant. So that's how you graph them. Now the same thing happens on the secant. Let me do one of those. Okay, here is my value, right? So pretend it's y is equal to cosine 1/4 theta. I'm going to find this chart and do the exact same thing. First of all, I find my period. So 2 pi divided by 1/4, oh my goodness, 2 pi divided by 1/4 is 8 pi. So my period is 8 pi. So on my chart, my t-table, I'm going to go from 0 to 8 pi by 1/4 of that, which is 1/4 of that is 2 pi. So it'll be 2 pi, 4 pi, 6 pi, 8 pi. And now I'm just going to find the cosine at 1/4 of 0. The cosine is 1, right? Right? The cosine is 1, because 1/4 of 0 is 0. Cosine at 0 is 1. At 2 pi times 1/4, think about that. That is actually at the top of the curve. The cosine is 0. And then at 4 pi, you've gone times 1/4 is pi, and your cosine over there is -1. Then it's 0, then it's 1. So if I think of this as a secant, everywhere I see a 0, that is my vertical asymptote. And these are going to be the bottoms and the tops of my graph. Let me show you again. So I'm going to number this. Okay, so my asymptotes look like they're at 2 pi, again at 6 pi, I'm sure again it'll be at 10 pi, and you can just continue. If you number it well, you just have to, look at your spaces and see how far apart they are and continue that pattern. So there's my vertical asymptotes, and now everywhere I see a 1, like at 0, it's 1. Let's call that 1. Call that -1. And that actually is where it opens up. It's asymptotic. And at 4 pi, it's -1, so that's actually my maximum, and it goes down. And then at 8 pi, it starts at 1, goes up. So you can imagine if you had 2 or 4 or 6 for your amplitude, that's where those bases would be. That's where the maximum and minimums would be. So now that's how you graph these. Hope you wrote down those directions. And I do have some screenshots if you want them. Here's the one for the cosecant from that website at Regents. Here's how you do the cosecant notice. And see how it looks, how it's a reciprocal of that sine. Remember, sine goes through the origin, original sin. And here's a cosecant. I'm sorry, here's a secant and the cosine. The purple is the cosine. So here's some notes if you want them. If you want to screenshot that, put it in your notebook. But I hope this is a clear enough directions to start so that we can just start graphing these and you can go by your directions, because we need a lot more practice time in class. So I need to truncate the revamping of these videos and going over them too slowly. You guys, take care.